Alright, in this video you're going to be introduced to a number of elementary relations. Up to this point, most of the relations we've looked at have been linear, and so we're going to start with that type of relation, just as a review. And let's do an equation, g of x of 2x plus 1. You'll remember from earlier grades that a linear relation is one in which the equation is first degree, the highest exponent in any of the terms is 1, and the rate of change of y is constant for a given change in x. So let's just do a set of sample points for this relation. If we input 0, 2 times 0 plus 1, out comes 1. If x is 1, we get 3. X is 2, we get 5. X is 3, we get 7. Let's do some negative values of x. It's always good to do. 2 times negative 1 is negative 2 plus 1, negative 1, and x equals negative 2 is negative 4 plus 1 is negative 3. Now when I graph these, I'm going to see that this forms a line. The other way I know that it's a line is because if we look at the rate of change, it's constant. We're always adding 2 units for every 1 unit of change in x. So if we plot these points, these sample points, remember there's an infinite number of points we could have calculated from for our table. This is just a sampling of them, and since we want to show all points, we will connect them because we want to show the points in between, all the real values in between that satisfy this relation as well. The domain. Okay, and we could have inputted any value of x. So to say all values of x, we say x is a real number, any number, positive, negative, fraction, decimal. And which y values come out? I can see that I'm getting negative and positive y values. If I just randomly pick a y value here, let's look at right here, 5.5. Is there a point with a y value of 5.5? Right there. There's some x value that associates with that. So all values of y are being used. And is it a function? Yes, it is. Because each x has one y. The next type of relation we're going to look at is a second degree equation, which we call a quadratic relation. And I'm going to set up a table of x versus y. If I substitute in 0, 0 squared, out comes 0. 1 inputted, squared is 1. 2 inputted, squared is 4. 3 becomes 9. If I input a negative, I will have to bracket that and square it, so 1 will come out. If I put in negative 2, squared is 4. This is clearly not a linear relation because there is not a constant rate of change. There is a pattern, but the rate of change is not constant as in a linear. So this is going to produce some other kind of graph. Let's just see what it produces. So plotting the points, I'm getting a pattern like so. I connect the dots because if I was able to calculate every single point, it would fill up this pattern. And I get a shape like so, and the shape of this graph is called a parabola. Parabolic reflectors, satellite dishes, the cross sections are parabolic. Now my domain. Which values of x was I able to input? Well, I could have inputted any value because I'm able to square any value. So x could have been anything. X could have been any real number. And the range, what kind of values come out? What kind of y values are these? If I square a number, I'm going to get a positive value always. The lowest I could get is 0, because 0 squared is 0. So y is greater than or equal to 0. Any real number greater than or equal to 0 is my range. And is it a function? Yes, because it passes the vertical line test. Each x has one value of y. Our third type of relation is a cubic. If I input 0 and cube it, I get 0. 1 cubed, 1. 2 cubed, 8. Negative 1 cubed. would be -1, -2 cubed, -8. If I plot those points to see what the pattern is, I get a shape like that. Okay, kind of comes like that. That's the shape to expect when you're dealing with a cubic relation. So which values of x are being used? I could potentially put any value of x in, so that's the domain, what I could put in. And what types of numbers come out? I can see I get positives, negatives, 0, so any number can come out. And does each x produce one y? I can see from the table it does. I can see from the graph that the graph passes the vertical line test. So is it a function? Yes, it is. Alright, here is an entirely new concept called absolute value, which is represented by 2 bars around the x. And the output of an absolute value is always the positive of the number that was inputted. So if I input 0, the absolute value of 0 is 0. If I input a positive value, any positive value, what comes out is the same number. But if I input a negative number, what comes out is the positive of that negative number. So -1, out comes 1, -2, out comes 2. And if I graph these points, I get what looks like 2 lines connected at a point, kind of a V shape. That's the typical shape of an absolute value graph. So domain, what could go in? Any value of x could go in, but what comes out? Range. Positive values come out, the lowest of which is 0. So y is 0 or bigger. And does each input produce one output? Yes. Therefore it's a function. The next relation is the square root relation. Now, if I think about square rooting, the smallest number that I can square root is 0 because I cannot square root negatives. I can't square root -4. It's not possible. So the lowest number I can square root is 0. Now that relates to the domain. My domain values, my x values, must be 0 or bigger. The square root of 0 is 0. The square root of 1 is plus or minus 1. The square root of 4 is plus or minus 2. But remember that this symbol tells us to only take the positive value, the positive square root value. So we're going to put 1 here, and we're going to put 2 here. That's typical on a calculator. If you plug in the square root of 4, it's going to say 2, even though 2 squared is 4, and -2 squared is 4. There are 2 square roots, but this symbol is reserved for the positive one. And the reason the calculator does that is because it likes functions. It wants to have one output for each input. And so a decision has been made that when this symbol is used, we represent that to mean only the positive square root. So when 9 goes in, 3 comes out. So off we go to graph this. 0, 0, 1, 1, 4, 2, 9, 3. We get a graph that starts there and it swings up like so. And so our range, the types of values coming out, we have a low of 0 and we have y values that are bigger than that. Y is real. And is it a function? Yes, it is, because the graph passes the vertical line test.